No.
Not yet, Prof.
Okay. What's the problem? Why? No, you can't still see. Yeah, you gave me the permission. Why can't? So you can't see my screen at all?
Here, not yet, Prof.
No. What's the problem? Okay. Camera on, microphone on, sound on, connection is secure. It's all good. I don't know why I can't share.
Maybe I will allow you to be co-host, maybe.
Yeah.
Okay.
Okay. So no, still it doesn't come up. I don't know. No luck. Share screen. It's all there. Enable waiting room, hide profile. No luck. Sorry, Dwike. I don't know what's happening.
Okay. Or maybe you can send me the file and I can help you to share the screen.
It's very big, so I will not be able to send it. But it says sharing is allowed. Yeah, it says sent. Okay, let me try this. You can't.
Okay, Prof. It is okay. The screen is already shared. Oh, I'm sorry, Prof.
Sorry, I'm
The
sorry.
screen is off. The share screen is off again.
I will go back and then I'll join in once again. Let us see whether that helps.
Okay, it's okay.
Okay, so I'll just get out of this. Leave. Yeah. Let me try once again. Post
Yes, sir.
disable. You please enable the screen sharing.
Okay. Please you can try once more.
No. I don't know what's happening.
Last time you were
Okay.
successful once time.
Yeah, that is
Share the
because I
screen.
was trying to share the tab, but it says please grant browser access to screen sharing, screen recording. That's okay. I don't know what's the problem. One participant can share at a time. Multiple participants can share simultaneously. Okay. Still, I can't share.
Are you using Zoom from
Okay.
browser or
Yeah, I'm
from?
using the Zoom from browser. That's correct.
Okay, from browser.
Maybe I'll take another laptop and try with the different laptop. Yeah, because I don't know what's happening. Mm,
Yes, bro. Sometimes I use Zoom from laptop. There are many problems there.
yeah, I don't know what's happening. Sorry, guys. Yeah, maybe I will use a different laptop. It says it is allowing me to share the screen.
I already allow the
Okay,
participant to share
is there
screen.
anything that's happening? Can you no sharing at all?
Or maybe you can share.
Yeah, I don't know. It's like it is in the window.
Maybe you can share all of the screen, not
I
just
tried that
one.
as well, so that doesn't work. Let me try the my share drive. Then from the share drive, let me just try to see whether I can get it. I reformatted and changed some things, but I will not be able to do that. See that UNSW share drive login. Okay, let me try to share the Chrome tab.
Okay, bro. I already see your share screen. Hello, Prof. Srenatha. I'm sorry. Your microphone is muted. I'm sorry, Prof. Srenatha. You are still muted. Hello, Prof. Srenatha. I'm sorry. Can you hear my voice? Because I cannot hear your voice yet. Yes, we are already unmute, Prof. Srenatha. I'm sorry, Prof. You are already unmute, but there is no voice from you. Okay, please let me help you.
But, okay, now it is mute. It's unmuted.
Hello,
Can you
bro.
hear me?
Yes,
Hello?
yes, I can hear you now. I can hear you now.
Yeah, but as soon as I share the screen,
Yes.
okay,
Oh, I cannot hear you now, but the screen is already shared. Sorry, I also. Can you use the unmute button? Hello. Okay. Please try it right now because here you are already unmute, but I still cannot hear your voice. Yeah, I'm sorry, Prof. I don't have
okay,
any clue for that.
okay, now you can hear me. So what I will do is I will
Yes.
take another laptop, use the other
Okay.
laptop.
Yes, okay, bro.
I will leave from here.
Maybe it is because the Zoom from browser. Oke, mohon maaf mahasiswa dan Bapak Ibu dosen, sebenarnya ada masalah teknis tadi ya. Prof ternyata sedang menggunakan Zoom dari browser tapi tidak bisa, ya, ketika share screen ternyata tidak bisa aktif mikrofonnya. Ada Ada Pak Cip, Bu Eni, ada Bu Gindi juga di sini. Selamat pagi Bapak Ibu. Sehat-sehat semua Pak, Bu.
Alhamdulillah, walaupun tidak semuanya.
Jadi kampus apa belum kampus?
Saya di lab ini, Pak Dewi.
Iya, saya juga di lab.
Nanti
Backsoundnya-
agak habis
Oh,
ini
iya.
Pak, ke labnya.
Iya, nanti ada rapat nih. Terus ternyata belum join lagi sebenarnya. Mungkin Pak Cip pernah pakai Zoom yang di browser, Pak. Jadi masalahnya ketika share screen, mic-nya tidak aktif. Kalau
Saya pernah
mic-nya
pakai.
aktif, nggak bisa share screen.
Saya pernah pakai di browser, tapi belum pernah share screen atau semacamnya sebagai pemateri. Jadi hanya sebagai partisipan saja dan nggak masalah kalau di browser.
Iya. Jadi itu kalau sudah share screen, mic-nya tidak aktif. Kalau tidak share
Iya.
screen baru mic-nya baru aktif. Ya, baik, kita
Ya,
tunggu
ditunggu
saja.
aja.
Iya, Pak. Ini sambil nanti saya share ada link absennya ya, kalau nanti yang mahasiswa mengisi daftar hadirnya. Ini sudah masuk lagi Prof. Srenatha. Halo Prof. Srenatha.
Yeah. All good?
Oke, Prof.
Okay, so let me try to share the screen.
Is there still any problem, Prof?
Just give me 1 second. I'll just share. Yeah, can you see this?
Okay. Yes, Prof.
And you can hear me as well.
Yes, Prof.
Okay, that's good. Okay. All right. Very sorry, guys. Technical problem. It's echoing. Can you please mute your mic?
I'm sorry, Prof. Maybe it is from you.
Is it muting,
Yes.
echoing from my side?
Yes. Is there any other that is also echoing? Because here in our lab, in my laptop, is not echoing, Prof.
Yeah, it's echoing for me. Can you hear?
Yes, Prof. We are
Okay.
already muted. Everyone. Everyone is already muted.
Yeah, for some reason still it is echoing. Okay, it doesn't matter. Let me see what happens. Okay. All right, friends, how are you? All good? Yeah, that's very good. Good to see you people. Yeah, so nice. Beautiful. So what is the weather condition in Surabaya now? Is it hot?
It is already raining season, Prof. Every day is already raining here.
Oh, it's raining there. Okay,
Yes.
so it should be good, good, good. Let me stop my audio. If I don't know, if I stop my video, you can't see my screen then, right? Can you still see my screen?
Yes, Prof.
Yes.
Let me just, yeah, I have gone out, so it makes it better, I think. Okay. All right, friends, let us talk a little bit about intelligent systems. Okay, and in particular, let us talk about fuzzy intelligent systems. It is echoing, Dwight.
No, Prof. In my laptop is not echoing.
Okay, in my laptop, I don't know why it's echoing so much.
Or maybe your second device is the speaker is on in your second device.
Okay, I have closed that. Okay, that's better now. Thanks.
Okay.
Okay, all right, so that makes it better. So, okay. So we have got three words here: fuzzy, intelligent, and systems. Okay. So normally we start from the left whenever we write something, but let us try to come from the right side this time. So let us look at what are systems. Then let us look at what are intelligent systems. Then let us see what are fuzzy intelligent systems. Okay. So let us start with systems. Can any of you tell me what is a system? What's a system? I can't hear, sorry.
Hello, guys, students.
So, okay.
Any
Somebody raises the hand, then you can unmute them for Dwaiki.
somebody maybe you can listen. Okay, here is Nicholas Emmanuel Gavin.
Yeah,
You just
thank
can.
you. Okay,
Very
thank
good.
you,
What's
Mr.
a
Topik, for
system,
the chance.
Nicholas?
Can you hear me, sir?
Yeah.
Okay. My name is Gavin. Right now I'm in my fifth semester. What is system? So if I look at the screen right now, it's actually the answer is on the PowerPoint itself. System is a combination of element or component that work in unison. I think that's the correct answer because it's the PowerPoint,
It's
right?
echoing so much. I don't know what's happening. Okay. Yeah. What you are trying to say makes sense. That's correct. But it echoes so much. I don't know. Okay. Let me just go through that rather than asking you. And after that, you can ask any questions that you have got. All right. So when we talk about a system, we are looking at a combination of elements, components that work in unison. This word unison is the most important word that we have got. And when we say unison, so what is the idea? The idea is It should work together such that if you give an input to this system, it should be able to generate an output. If it doesn't generate an output, then you don't call it as a system. So when we give any input to a system, all these combination of elements or components that work together or in unison will try to generate a output. I'll put a number of examples here. So like a car. Car can be looked upon as a system. A robot is a system. An aircraft is a system. An economy is a system. And so like similarly, a classroom that we have got is a system. So when we say like car is a system, so you have got the input and you have got the output. So if you look at the input as the steering by the driver, then the output of the car is going to be change in direction. If the input to the car is the accelerator, then the output of the car will be the speed that you are going to get from the car. If the input is braking, then the output is going to be slowing in the speed that you are going to get for your car. So similarly, a robot, depending upon what is that you are looking at, what type of robot that you are looking at, it has got a particular input and it is looking at a particular output. So let us say that if you have got a ground robot and we want it to go around the room. So that go around the room is a command that is given as an input to the system. And the robot will go around the room. So which is the output that we are looking from the system. So similarly, when you are looking at the economy, you can look at it as a system. Can we look at the classroom as a system? So is classroom a system? Yes, because the idea is I try to give you some input and the output is the knowledge that you are trying to get, which you can use at some other place. So when you go out and tell others that, okay, you have learned a little bit about intelligent systems, so that becomes the output that you are looking at. So in general, so whenever we talk about a system, so it has to have an input, it has to have a output. If it doesn't generate an output, it becomes like a black box. So those systems are useless for us. So it has to generate a output. Practically, any system that you think of will always have an output. Okay. So when we talk about these systems, in general, we talk about these systems as either linear systems or nonlinear systems. So when we say linear systems, so what is that we are trying to talk about? So most of the time when we talk about linear, you can associate a straight line with a system. So that means the output is proportional to the input. And when you say proportional, it is practically directly proportional to the input. So that means I can predict the output if I know the inputs for a number of samples. So if I have got, say, like an input, and if I get an output, and similarly, if I get another input, and if I get the output, using these two inputs and the two outputs, I can predict the output for any other input that we have got for the system. So which we simply call as what is known as the principle of superposition. So any system that follows the rule of principle of superposition, we call such systems as linear systems. For example, so you have studied physics, then you have studied mathematics. So when you do a robot course, you are trying to use the input as a combination of physics and mathematics. So if you can do that, then your mentality can be looked upon as a linear system. But when we talk about nonlinear systems, so any system which is not linear, then we call it as a nonlinear system. For those nonlinear systems, the principle of superposition doesn't hold good. So that means you can't predict the output very easily as a linear combination of the inputs. There may be a nonlinear function, say like an x square function or an x cube function. So if you have got nonlinear systems, then they're not very easy to deal with. But any practical system that we have got, like a car, a robot, an aircraft, or even a classroom which has got human beings, is basically a nonlinear system. So we have to deal with these nonlinear systems continuously in our practical life. But most of the tools that are developed have been developed for linear systems. So what we sometimes try to do is we try to approximate a nonlinear system as a linear system and try to do the work. But it may not be the right way of doing it because you are trying to do an approximation. So when you want to get accurate results, we try to deal with nonlinear systems directly. Okay. So it doesn't matter whether it is a linear system or a nonlinear system, because it is a system, you have got an input and you got a output. And when we talk about the output, so the most important thing is we should be able to measure that output. If you are not able to measure the output, it just doesn't serve any purpose, right? And how do we measure the output? So to measure the output, the instrument that is used is called as the sensor. And as human beings, we have got a number of sensors. The eyes that we have got, they are the sensors because they can visualize what is happening around us. So they try to give you the output in terms of vision. The ears that we have got, they give you the output in terms of the audio. Any sound that is coming out from outside, we can hear, right? So similarly, the skin that we have got, so it has got sensory touch. So the moment you touch a hot surface, so it is going to tell us that, okay, it is at 45 degrees, 50 degrees, 60 degrees. So we have got sensors in that sense. So like these car, robot, aircraft, when we talk about, they all have sensors. And that's a very, very important component of a system. All right, are we going all right? So you guys are okay? Okay. Okay, so what happens many times is the output that we get from a system is not useful. For example, so you attend a class in mathematics. The idea is you want to learn mathematics and pass the course in distinction. But you may not be able to get distinction. You are likely to get only a pass. So the output that you are getting still is a result, but it is not a useful result as far as you are concerned. So what do you do then? So if the output is not going to be distinction, so what are you going to do? So the first thing that you can do is you can modify the system. You can't change the system, but you can modify the system. So what do? You study more, you concentrate, correct? So that's basically what we are trying to talk in terms of modifying the system. Let us say that you have already put in all those in terms of to help yourself by concentrating, studying more, but still the output is not what you are expecting. So it is not still going to give you the distinction that you are trying to look at. What do you do then? Then you try to add an additional element, which we call as the controller, to improve the system. So what is the controller that you are going to use to improve the marks that you have got? You can use your friends. So your friends can help you to make you understand better and write better so that you will get distinction from your course. Similarly, if you go and talk to your lecturer, the lecturer can help you to give you more guidance. So how do you read? How do you study? And then how are you likely to get better marks? Okay. So that way, the additional element that you are trying to use is called as the controller. So this controller, along with this loop or the system that we have got, can be used to make the output useful. So whenever the output is not useful, we try to use a controller for making the system better. And when we use this controller, many times, or most of the time that we come across, we have got two ways of dealing with those controllers. One is known as a open loop system. The other one is known as a closed loop system. So when we talk about a open loop system, so what happens is, so you give an input, you are going to get an output. So what is the best option that you have got? You have to modify your input if you want to change the output of your system, if you don't want to change your system. So that controller that you are trying to place is trying to take an input, modify that input so that that particular modified input goes to your system. And if that can be done without worrying about what is the output that you are going to get just by practice, then you call such systems as open loop systems. For example, so like when you try to ride your bicycle, you just try to learn how to ride your bicycle by practicing more and more. And when you practice more and more, you don't have to think about it. So you can just ride the bicycle. So then it becomes a open loop system. Similarly, if you have got a stone in your hand and throw it at mango, so quite likely that first time it may not hit. But if you train yourself a few times, then you will be able to hit it. But once you throw the stone, there is no way that you can modify the trajectory of your stone, which is what used to happen in earlier generation of missiles as well. So you just use a missile, fire the missile, and that's it. It is like using your bow and arrow. Okay. So if you are trying to use the arrow, what all you can do is you can keep it in a particular direction and fire it. And once you release it, you can't do anything with that. So that's basically what open loop systems have got. But they're not really very useful. What happens is, if you are trying yourself to do a particular job, if there is a change in the, either a small change in the system or a small change in the environment in which you are trying to work, then your training may not be very beneficial. It is like if you have learned yourself to use the bow and arrow, say like in Surabaya, in say like indoor environment, if you go outside and try to do the same thing, because of the windy conditions, you will not be able to achieve the same target. So that is one of the major disadvantage of the open loop system. If there are any changes either in the system or if there is noise which is external to the system, then these open loop systems are not very good. So to overcome this, we are trying to use closed loop system. So in the closed loop system, the input to your system, which goes through your controller, keeps getting modified based on the output of your system. So if you are using continuously the output to modify the input, so that means there is a link between the output and the input, then you call such systems as closed loop systems. The way I'm trying to talk to you now has become an open loop system. So what I'm trying to do is, at the end of every slide, I want to stop and ask you what's happening. So I want to get a feel of what's happening, which is basically trying to say like, I want to close that loop. All right. So most of the systems that we come across in nature are closed loop. When you talk to your friend, it's a closed loop system. When I lecture in the class, theoretically, it should be a closed loop system. So like when you talk to your friend, you keep looking at the reaction from your friend. Based on the reaction from your friend, you modify what you are trying to talk to your friend. If your friend is angry, then either you move away or you reduce your tone. If your friend is very happy, then you are also very happy, and then try to share more information. So depending upon the output that is basically coming from your friend, which is used by your sensors in terms of the vision, the ear that you have got, possibly if you are also trying to use your sensors, other sensor like hand or something else, then using that information, then you try to make yourself so that the output is become a useful output. And when you have got these closed loop systems, they have got very good properties in terms of noise rejection, and they can also handle what are known as parameter variations. So what are these parameter variations? So in any system, say like in your car, you have got mass as one of the parameters of your car. But the mass of the car can change depending upon the number of passengers, the amount of fuel that is there. So if you want to ensure the same speed, then as a driver, which is basically a controller, you still ensure that you give a certain amount of fuel or modify the amount of fuel so that you still get the same speed from your car. So that way, the closed loop system can handle noise. It can also handle parameter variations. And any system that can handle noise and parameter variations, we call such a system as a robust system. Because they are robust, we want to have closed loop systems for car, robot, aircraft, economy, or even in the classroom or anywhere else that you go across. And for a closed loop system to work, you should be able to measure the output. So these sensors are very, very important component of any system that you have got. And particularly, we'll talk about them to say that they are very important components of intelligent systems. All right. So are we going all right? So you people are getting something? Is it okay? Yeah, that's good. Okay. So you want me to slow down or is this okay? Okay. Do you want me to slow down further? Can you understand my English?
I think his pace is okay, sir.
Is that all right?
Yeah, I think it's all right.
Okay. Thanks for that. Okay. When we talk about these closed loop systems, so in general, some of you who have done the control course or signals course will have seen a block diagram like this, where you put your car here, you put your driver here, or which is like a controller that you have got. Then anything else in the feedback, which is like a sensor that you might have got, or if you have got a sensor here, then you might have an amplifier to amplify that feedback signal. Okay. So in general, you will have a system which has got the system, a feed forward element, which is like a feed forward controller. Then you have got a feedback element. Sometimes you can also have a feedback controller. So depending upon the way that you are trying to put in, you can get a relationship between the output that you are looking for your system and the input. And this input for a closed loop system, we generally call it as the reference signal or the command. So if you are looking at a robot, like a ground robot, the command is you go to that particular point, and the output is the displacement that you get from the robot, and it reaches that particular point. To do that, it has got this controller, which is trying to use the information that is coming here and modify that information and gives it to the robot in terms of the linear velocity and the angular velocity. And the output is basically the displacement that you are getting from your robot. And that output is measured using some instrument. So you have got a lot of instruments which can measure the output of your robot in terms of the displacement. So if you use any of those instruments and try to get that output, you use that output to compare what is the command output. If the command output is the same as the desired output, then you say you have achieved your purpose. All right. So we can write a mathematical relationship between the output and this input using this system, the feed forward element and the feedback element in this form. All right. And this error signal is something which is very important because every control system is basically driven by the error signal. And I'm going to use this error signal once again little later. Okay. And as a closed loop system, it has got, in terms of the pros, it has got very good noise rejection capability, and it is insensitive to parameter variations. But anything that comes with pros, it also has got some consequences. So the negatives of a closed loop system is you need to worry about what is known as stability of this system. So what is stability? So when we talk about stability, if I give an input to a system, so like if I give an input to the system, and if the output is going to be bounded, then we call this system as a stable system. Or if there is a disturbance on the system, and if the disturbance is removed, the system output comes back to the original condition, then we call such systems as stable systems. So if you have got your car, and if you give the input as the accelerator, then you expect a certain output from your car in terms of the speed of the car. Sometimes, when you have got a closed loop system, and if the driver is sleeping, or if the driver is looking somewhere else, so what is likely to happen then? Then you are going to meet with an accident. If you are going to meet with an accident, so how does it feel? So your output of the car in terms of the speed is going to be something entirely different. So then you call such a system as an unstable system. So when you have got a closed loop system, so you are likely to get into this instability. So most of the systems, when we design the closed loop systems, we worry about the stability first, and then we worry about the accuracy of our output. All right. So is this okay? So are we going all right? No problem?
Yes, sir.
Okay, any question? Any doubt? You can put it in the chat, that is easier. Any doubts? No? Smart kids. That's very good. Okay. So we looked at systems. Okay. So first we looked at what is a system. Then what is looked at what is a closed loop control system. Then we looked at open loop control systems. Then we looked at closed loop control systems. And practically everything in the world that we come across, there are closed loop systems. So let us look at now the second word that we had, intelligent. So the first thing is systems, that is done with that. Now I am looking at intelligent. So what is intelligence? So when you say somebody is very intelligent, so what do we mean by that? So do we mean to say that in a different environment, that person can still do a good job? then do you call such a person as intelligent? Is that true? So that is possible only when somebody has trained himself to think and act based on the thinking that we have got. So this capability to think and act adds on to the intelligence. So we need to somehow build this thinking capability into our systems. If we can build our capability for thinking and acting in the presence of any disturbances or any changes, then we call such systems as intelligent systems. So this intelligence has got to do with thinking. If there is no thinking, then there is no intelligence. So do you all agree with me? Okay. So how do we build in this thinking capability? So what are the ways that we have got? One of the easier ways is you can train. All right. So if you keep training somebody, we hope that they will be able to think. Is it true? Is it always true? No. Because just by training, what we are trying to do is we are trying to expose them to different circumstances or changes. But if there is a change in the environment, or if there is a change in the outside circumstances that are there, this training may not be able to be just used directly. So then they have to relearn. So if they can relearn based on the environment that they have got, then they have got the thinking capability. All right. So when we talk about this learning, so there is how to learn, then the second one is when to learn, third one is what to learn. When you have got this when to learn, that basically makes a system as intelligent. How to learn is perfectly fine. So like you come to the class, you do 10 problems, what the lecturer talks to you, you go home, do another 10 problems. So that becomes, say, like a supervised training first, then a bit of unsupervised training. So you try to learn using the lecturer as supervised training, then possibly you go home, then do some more work, which can be something looked upon as unsupervised learning. So you know how to learn, all right? But then you also know what to learn, because what you are trying to do is you are trying to study for your exam. So you go through past papers for the last 5 years, then use your how to learn capability to learn that. So you have practiced the solutions for those 5 years. So which is what we call as what to learn. But does that make you intelligent? No, because when you go to the exam, quite likely you are going to get a problem which is different from what you have learned through the supervisor, what you have learned in the unsupervised way, and which is not available from the previous 5 years. At that time, if you can think, if you can modify the learning that you have learned to ensure that you are able to solve that new problem given to you, then you are intelligent. So that is the difference between when you say like somebody is intelligent, because given a different problem, based on the training that you have learned or going through the process of learning, you can modify the learning to ensure that you will be able to deal with the new problem that is given to you. So how do you know that it's a new problem given to you? So that is based on the circumstance that is there. So if you are sitting for an exam in the classroom, then it is one circumstance which you are trained. But if you go for a competitive exam, then it's a different place that you are there. And similarly, if you have learned mathematics, say like you have learned a lot of differential equations, somebody asks you a little bit about the solution of differential equations in a slightly different way. So like using basic principles like difference equations. And if you are able to do that, so that means you can modify your thinking based on the circumstance that you have got, then you are smart and intelligent. We all want to be smart and intelligent. Practically all of us are smart and intelligent because you train yourself in the home. The moment you go outside, you behave with the outside people in a smart way so that you are able to talk to them and you are able to convey your information to them, which is basically what your smartness or the intelligence is trying to tell you. You are not simply repeating what you have learned in the home with your parents or your teachers. So that way, everybody is smart, but that smartness has to be built in using the process of training and then the circumstances that you have got. So how do you measure these circumstances once again? Or the changes in the circumstances, once again, they come from the sensors that we have got. All right. And many times when we do this training process, so along with supervised training and unsupervised training, your parents have also tried to use what is known as reinforcement learning. What is reinforcement? Like reinforcement stands for keep enforcing the same thing or keep repetitively telling the same thing so many times. And every time when you learn something, then either you are given an award or if you don't learn, you are given a punishment, which is what all the parents have done to you. When you were kids, if you have been naughty, when they say don't do this, then they are trying to give you a punishment so that that punishment deters you from not doing that. At the same time, the parents, to make you better and to ensure that you do well, they have also tried to give you award. So let us say that they tell you, if you do well in the examination this time, I'm going to get you a bike. So that bike becomes a reward. So you get the reward when you achieve the marks, what your parents are looking at. The same time, they can tell you that if you don't do well, quite likely I may take off your mobile phone. So that becomes a punishment. So this reinforcement training has become one of the important ways in which we use this supervised and unsupervised training. So in the supervised training, the reward or the punishment, whichever way you can look at it, is given by the supervisor. In the unsupervised training, the outcome that you are going to get, you modify yourself so that the output that you are looking from the system is going to be better. So a combination of supervised and unsupervised learning is mostly used in reinforcement learning, which is one of the intelligent ways of learning, which all human beings do. Sometimes we call it as semi-supervised. So is that all right? So are we going okay? Okay, perfect. All right, that's very good. Okay, can one of you give me an example for supervised training that you have gone through? So once again, you can put it in your chat. Anybody? Yeah, some example, simple example. It doesn't have to be very complicated. Yeah, can you give an example? Yeah, one example of supervised learning is general lecture. That's correct. So you are trying to learn using the process of the lecturer, and you listen to the lecturer. Along with listening to the lecturer, you also look at the slides. So there is an additional reinforcement in terms of the material that is going into your head. So that way it becomes a supervised learning. Any other example? Simple example from life where you have gone through the supervised learning. How did you learn to walk? So you can answer me on the chat. Training, animal circus. Yeah, that's true. That's a supervised training. Perfect. Yeah. Bicycle train. Before that, okay, that's a good idea. Bicycle train is a supervised training that initially you started with. Okay, much more natural to that, natural than that. Your dad or mom holding your finger and making you to walk along with them. Is that right? Did you all go through that process? Did you all go through that? Like your dad and mom initially holding your hand to make you to walk?
Yes, sir.
Yeah, that's correct. Then that became a supervised training. But then what you did is after that, you started practicing yourself by falling here, there, and other things so that you became confident in your walking. And that you did initially only in your home. So that becomes something like a unsupervised training to become smart. So what did you do then? So when you go out, right? So like quite likely that you may be going on a gravel road, you may be going on a slippery road, which is icy. So, but then because of your thinking process and the training that you have gone through, you can walk on those paths which you haven't practiced in the home, because in the home, everything is very neat, right? There is no icing or there is no gravel. But when you go outside, quite likely that, okay, you may have some ditches on the road. Then by your thinking process, you can jump over that ditch or cross that ditch without going through that. So that becomes what you have learned and you become intelligent. And everybody, as I said, is intelligent. There is nothing to say that somebody is intelligent, somebody is not intelligent. Somebody is intelligent in some things, somebody else is intelligent in a different thing. But practically all of us are intelligent. That's one thing that makes the human beings different from the animals, where we can think better than what the animals can think. And what do we do for this? So whenever we want to change the way that we think, we try to use our sensors, because these sensors are going to give us information about the changes in the conditions that we have got. Or if there is any new information that is coming, then that information is coming through your sensors. If you don't have sensors, then realistically, we don't have any intelligent systems. So these sensors are something which is very, very important for intelligent systems. And using these sensors, we use the feedback control systems to ensure that everything that we come across will be able to give you the desired output under all conditions. If we can do that, then we have got smart systems. So anything that you talk about a robot, which is a smart robot, basically has got sensors which can give the information about any changes in the conditions that it hasn't seen and any other new information that is coming onto it. And that sensor information is used in the feedback systems so that the controller can modify the thinking process so that the output is going to be a desired output. And if you have more sensors, then you have got better intelligent systems. Can anybody tell me how many sensors are there in something like a Tesla car? And what are the different types of sensors that are there on something like Tesla car? Any idea how many sensors are there in a Tesla car? Ten, 20, more than 20? Yeah, possibly. Any other number? 30? More than 30? $12? Yeah. So what are those 12 sensors? Did you see it from the Google? Yeah, that's the autopilot system only, which uses 12 sensors. But there are other sensors as well. So there are nearly about 100 sensors in Tesla car. And they are increasing the sensors more and more. Quite likely that we'll be seeing 200, 300, 500 sensors sooner. Okay. So we have got about at least 100 sensors that are sitting in the car. So when you are looking at the autopilot system, you are looking at these 12 ultrasonic sensors. All right. So what are ultrasonic sensors and what do they give you? What is the information that you get from ultrasonic sensors? Distance. Perfect. So what is the use of this distance? You can use it for obstacle avoidance. Correct. So this autopilot system that is there in Tesla, when it uses 12 ultrasonic sensors, is basically used to avoid the obstacle. So when you want to park your car, it can give you an indication of how far you are from the wall. If you want driving forward, it can tell you like there is a car in front of you. If you are trying to change the lane, it can give you an indication to say that there is another car next to you. So that information basically comes from these ultrasonic sensors. And you can also have the forward radar, which can also give you the information in terms of reading the lanes, so that it can tell you like whether you are crossing the lane or not. So that information is used to ensure that you stick onto your lane. Okay. And any other sensor that you can think of? In the Tesla car, any other sensor you think that it is there? You have a basic sensor like a temperature sensor. Is there a temperature sensor inside the car? Yes. So where is the temperature sensor and what is the purpose of the temperature sensor inside the car? So where is your temperature sensor? Yeah, to monitor the temperature of the engine. Perfect. So that is the basic sensor that you have got, which is inside the engine, so that the engine temperature is monitored continuously. So that becomes something which is useful, because if the engine temperature goes beyond a certain limit, then either the engine is shut off or it gives you an indication to say that you stop your car now. That is a very important sensor. Second sensor in terms of the temperature is what you have got for the cabin temperature, so that the passengers feel the comfort. So you can set it to 20 degrees, 21 degrees, and then the temperature sensor will ensure that The AC will come on whenever the temperature goes above the value of 20 degrees. That's nice. That's very good. So you have got something like a basic sensor there. And the same sensor is used in the feedback system as well. All right. And when we use these sensors, so and when we talk about the control systems, basically we talk about classical control systems, or we can talk about adaptive control systems, or we can talk about evolving control systems, and we also talk about the fuzzy control systems. All right. Most of the classical control systems, they basically work upon mathematical functions. The first thing that you do for any system is you get a mathematical model for your system. Then use that mathematical model and the output from the sensors to ensure that you design your control system such that the control system will do the job of tracking the command so that the output error is going to be reduced. So when you have got this classical control system, everything is talked about in terms of mathematical functions. Can you give me an example for a mathematical function for a dynamic system? When you talk about dynamic systems, what is dynamic and what is the mathematical model that is generally used for a dynamic system? No idea? Okay. When you talk about dynamic, it's basically changing with respect to time. So when you say you have got a robot, if it is sitting in the corner, it becomes a static system. If it is moving around, so that means the displacement is a function of time, then it becomes a dynamic system. We are all dynamic systems because we keep changing ourselves with respect to time. So that's basically what a dynamic system is. And in your mathematics, you have learned about differential equations. Have you learned differential equations? Have you learned differential equations? Yes. So the differential equations, and when the differential is with respect to time, so those differential equations represent the mathematical model for your system. A robot can be modeled as a differential equation. A human being can be modeled as a differential equation. The money that you spend can be modeled as a differential equation. The economy of the country can be modeled as a differential equation. When you learn your differential equation, they just taught you differential equations. But in terms of applications, practically, these differential equations are everywhere. So there is no way that you can get away from the differential equations. But when you learned your differential equations, many of you must have thought that they are not very easy to learn. Is it correct? Did many of you think that differential equations are difficult to learn? Yes, no? So if they are difficult to learn, and many systems we also learn without differential equations. As human beings, we don't have differential equations with us. So how do we learn? So how do we model ourselves? Can you model your friend? Can any of you try to model your friend? Have you tried? Have you got a model for your friend? Maybe in terms of, say, like a simple reaction. Have you been able to model your friend in terms of simple reaction? Have you tried? Or have you tried to model your dad? Have you tried to model your mom? Yes. So how do you model your mom? You know that if you do well, your mom will be happy. So that's a reaction that you are getting. So how did you learn that? You tried by doing different things. Then you found out that if you do good things, mom will be happy. And if she is happy, she's going to cook nice food for you. So if you want to get good food, you need to be good with her. So that's a rule that you have formulated. And if you don't go home in time, she'll be upset. So that's a rule that you have learned. So you can model your mom in terms of rules, which is what we try to do. So many times, instead of the mathematical modeling, we try to use these rules to model anything that is given to us. So can you do the modeling for a robot? Have you learned your car using differential equations? Or did you learn your bicycle driving using differential equations? No, you just learned it by practice. When you say practice, you created the rules, and those rules are used to model your car or to model your bicycle. So that way, we can use rule-based modeling for any system. So what we'll do in the next class is we will use rule-based systems, and Fuzzy is one such rule-based system which can be used to model your system and to model your control systems. And the advantage of these fuzzy rule-based systems is they are adaptive and you can make them evolving. What is the difference between adaptive? What is adaptive and what is evolving? Any idea what is adaptive? What is adaptive? Are you all adaptive? Yes. Are you all adaptive? Yes, no? So are you all adaptive? It is true. It's a dramatic reprisal and reframing of the concept of human intelligence. And when we talk about adaptive, in a simple way, we can look at it to say that, so you have been listening to your lecturers from Surabaya, and you have been able to understand what they say. Similarly, when you are sitting in my class, and if you are able to understand what I am trying to say, that means you are adaptive. You can adapt yourself to different types of English that you are going to get. And the information that is being passed on to you is in different ways, but you are still able to get that information, which is basically what an adaptive system is. And what is an evolving system? Any idea what is an evolving system? Yeah, what's evolving? No idea. When you went to the high school, you learned something. Then you went to the college. What did you do? You evolved or improved yourself so that you can get the grasp of what's happening in the college. From there, you evolved yourself so that you can come to Surabaya and do your degree. And then when you finish from here, you are going to get a job. You are going to evolve yourself so that you'll be able to do the job that is given to you, which is basically what the growing or improving yourself stands for. So that improvement, if we can build it into a system, then it becomes an evolving system. So it's better than adaptive system, because adaptive systems also have got limitations. Whereas if you can evolve yourself, then it is a better way of dealing with the systems. So most of the intelligent systems that we want them to evolve based on the sensor data that you get. And that sensor data is basically used to get an information about any changes in the environment or any new information that is coming onto your system. So in the next class, we will use this fuzzy system. We will talk a little bit about fuzzy system, which can give you rule-based system so that you don't have to worry about differential equations. And then let us see whether we can make them adaptive and evolving. If we can do that, then we land up with fuzzy intelligent systems. All right. So I talked to you for about an hour. So I'm sorry for the initial problems that we had. Okay, so we will meet next class to talk about fuzzy systems. Any questions? Any doubts? No questions? They're all very smart, right? No questions?
I'm sorry, sir. Can I ask a question?
Yes, definitely. Can you write the question? Because I
Oh.
can't, it is still echoing.
Okay, so let me write the
Nicholas, do you have question?
yeah, yes. Should I still write it or?
I can't. Yeah.
Yeah.
Can you write the question, please?
Yeah, all right.
Yeah. Main difference between adaptive and evolving. Correct. For me, that the purpose is to adapt to environment. Correct. So when you say adaptive, so basically you are trying to say that you have gone through your learning phase. Okay. What you can do is you can adapt yourself to a different environment. So that's basically what you are trying to do. So like you studied in Surabaya, and if you go to IT Bandung, let us say, then you will be able to cope up with what is happening. So you can adapt yourself to the different environment that you have got by simply modifying the parameters of your learning. So there is a way that you can modify your parameters, but you can't learn new things. The moment you start learning new things, you start evolving. Does it make sense?
Uh, can I write my response? I'll write the response.
Still,
Ah.
sorry, can you
Yeah.
please write it?
Okay, okay.
I'm sorry, I don't know what's happening. It's echoing so much. I can't hear. It's old knowledge, but modifying your knowledge. So that knowledge is fixed. You are simply playing around with that knowledge as a parameter. So you are changing the parameter of that knowledge, then you are an adaptive person. Whereas if you have to learn new things, then you become evolving. Say for example, so do you play ping pong? If you play ping pong, so you have learned yourself to play ping pong. If you go and play in different places the ping pong, so what you are trying to do is you are becoming adaptive in playing ping pong in different places against different players. But if you use your ping pong technique to use it for playing tennis, because you know that the ball can be hit, you got a longer bat, but then you got a heavier ball. So if you can do that, then you are evolving yourself to use the same knowledge, to use it for a different purpose. The environment is different, but then you have evolved yourself to play tennis. Does that make sense? No problem. Thanks, Nicholas. Cheers. Yeah, any other doubt? Yes, Asanul, please write your question. I just want to understand more clearly the difference between adaptive and evolving. Adaptive is a temporary change of an already learned knowledge, while evolving is a new, more permanent. You can look at it that way, but in reality, adaptive is also a change that keeps on coming because of the change in the environment. Whereas if you keep learning newer things, then you are evolving. So like when you first started, you learned only Indonesian, but then now you are learning English. Then if you go to French country, you will be able to learn France. And if you go to some other place, and if you learn that language as well, then you are evolving yourself. So that way you keep adding knowledge to your base. Whereas in the adaptive system, the knowledge is fixed, but you modify that knowledge to suit the environment that you have got. All right. So probably like when I do a little bit in terms of the controller, so like a PID controller, I will try to tell you what is the difference between an adaptive PID and an evolving PID. So that will make it a little bit better. Okay. Yeah. Thanks, Arsenal. Any other question? No. All right. Thank you very much. I will see you in the next class. Gary,
Thank
my
you.
friend, where are you?
Hello, sir.
Hi, Gary. What's happening?
I'm in the robot now for the service.
Okay. You're looking good.
Yeah,
You're smart. That's good.
Yeah. Good.
So how did your project go?
Maybe 85%.
That's very good. Very good. Nice achievement. Congratulations. So how is your car driving?
No, sir.
Good?
Yeah.
So you're going to take me next time around when I come there? You are going to drive me next time when I come there?
What?
Yes.
Can you repeat, sir?
Next time when I come to Surabaya, will you drive me?
Okay. Okay.
Yeah, we had good fun. We had good fun. All right. Okay. All right. Thanks, guys. Thank you very much. Thanks, ma'am.
Thank you, Prof. Srenatha.
Thank you very much.
Thank you. See you
See you in the
next
next
time.
class.
Yes.
Bye.
Bye. Oke ya, sudah ya. Yang ATC tugasnya. Oh, Prof. Srenatha, I think that you already delivered this meeting.
Oh, I'm
I'm
sorry.
No, oh no, I just explained to the students. Okay, students, your task today is make some review for Prof. Srenatha class today. And the task link, I will upload it in the classroom today.
Sure.
Any question?
That will be good.
Thanks, Mom.
Okay.
Thank you.
Thank you, Prof.
See you. Bye.
Yes, I will end this meeting. Thank
Sure.
you.
Thanks. Take care.